Welcome to this eLearn Security video lesson on exploiting in banned SQL injections. In this video, we will see how to detect the number of fields used in a vulnerable select statement and their type. Moreover, we will use this information to extract information about the DBMS, the Web Application Backend Database, and the data it contains. We're going to study a web application hosted on example.sqli test. The web app provides some client management features. By opening clientinfo.php, a site administrator can navigate through a client's records and see information such as name, number of logins, and credit card information. Navigating through the records by means of the previous and next buttons simply means changing the ID get parameter. For example, we can directly jump to the 200 client by typing ID equals 200 in the browser address bar. If we choose an ID which doesn't exist, like 9999, the application displays just the skeleton of the page without any data. Let's try to inject some SQL commands. We start by choosing an existing ID, and then we append a single quote to it. The application doesn't display any data nor SQL errors, so we have to try a Boolean detection phase by injecting 200 single quote and A equals A. The application prints the data correctly, so ID is vulnerable to SQL injections. The query executed by the web application is probably something like select some fields from clients where ID equals the ID get parameter. We can inject a union select statement and find how many fields the original query has. Let's start by injecting union select null semicolon and a comment. We do not get anything back, so we keep incrementing the number of null fields in our payload until we correctly balance the queries. We correctly balance the queries by using 3 fields. Now we have to find the field types. Some DBMSs enforce type checks between union queries and some others don't. To find if this is the case, we start by injecting a string on the first field, ELS1. The query works, so the first field is a string. Let's inject a string in the second field, ELS2. This time the query no longer works. This means that we have to change data type. Let's test the field by injecting an integer, 22222. The query now works, so the first field of the query is a string, while the second one is an integer. Now, we can inject a string in the third field, ELS3. The query works. To actually display the results of our injected query on the web application output, we have to make the original query result set empty. We do that by setting ID equals 9999. As you can see, the web application now displays ELS1, 22222, and ELS3 on its output. We can exploit this information to get information about the DBMS and more. We will make the web app display the information we are hunting for on its output. Many DBMSs implement the @version special field name. We inject @version in the first field. As you can see, the database management system version is Microsoft SQL Server 2014. Knowing the DBMS version is a great resource, as this lets us write targeted payloads. For example, we can use the neat MS SQL injection cheat sheet provided by Pentest Monkey and integrate some of those functions in our payload. We now use the username function to retrieve the user that the web app is using to access the DB. The user is DBO. What if we need to find all the users of the machine? We can use the List Users entry of the cheat sheet with some custom modifications. To find the first user of the server, we can simply copy the entry as is and use it in our payload. Don't forget to fix the number of fields and add the comment at the end. We always need to filter out the remainder of the original query. This is the first user. To find the second user, we first have to filter the first out by appending a where clause to our payload. We force the application to display the second user. It's possible to iterate this process to find all the users on the DB server. Here, you see how to dump some of them. Let's use a similar approach to find the current database name by exploiting the db_name function. Here the web application prints the current database name, USR Management. In-band SQL injections are a really fast way to dump information and data from a DB. In the following videos, you will see some payload examples that will help you dump not only this information, but also the actual database structure and the data it hosts. Those payloads will also work for in-band SQL injection exploitation. Moreover, in the SQL map videos, you will see how to automate the dumping phase, but keep in mind that a thorough manual detection and initial exploitation are the only way to mount a targeted attack. This means that your attack will be stealthy as much as possible, and it will load your client's infrastructure as little as possible. And this concludes our video on exploiting in-band SQL injections. Thanks very much for joining us.